Okay, this is the second day of this lesson of our Computers 101 lesson, and this is about storage and software. I want you to take a second. On your assignment page, you'll see there's like a decoder box that tells you what letters are what series of ones and zeros. I want you to tell me the answer to this question. What purpose do flowers serve? So pause the video and then write your answer. All right, so assuming you paused like you were supposed to, the answer is bee feed. It was hard, so a little corny, but that's all right. As you may know, these ones or zeros are bits of binary code. This is why computers are digital, because they speak in a language that only has two choices, on or off, and we represent that as a 1 or a 0. Now, a 1 or a 0 isn't very useful to us, so we group them together in groups of 8, and those will represent some sort of character, and we call that a byte. So a bit is a 1 or a 0, a byte is 8 bits. So 0100000001 is the letter A. If you know binary code, there's sort of a pattern to it, but thankfully we don't have to memorize that anymore. Now, when we measure our data in bytes, they start to get pretty big pretty quick. So we use prefixes to help us so that we can categorize them. So kilobyte, 1,000 bytes, which sounds like a lot, but that's actually very small. The types of files that are measured in kilobytes are usually text files. Text is really the smallest thing we create on a computer. Mega, meaning million. This is what most things are measured in. So all of our digital images and music and most programs and apps are measured in megabytes. A billion, gigabyte. Well, videos are basically 30 pictures plus audio for every second. So as you can imagine, videos get big in a hurry. So videos are measured in gigabytes. Video games that kind of look like movies, those are measured in gigabytes. Huge programs like operating systems, those are measured in gigabytes. And then tera, trillion. Really, if there was a file, maybe a huge database, but I doubt that there's one, because once something is the size of a terabyte, it's really hard to move it around from one location to another. So it'd probably be broken down into smaller ones. All right, look at these two groups of things. The items on the left share a characteristic that the items on the right do not. So the items on the left are tangible. You can actually touch them. They're physical. Physical components to a computer are called hardware. So hardware, anything physical, if you can touch it, hardware. Software are just the programs. Programs are coded instruction for a set of tasks. Now, if you've ever done any programming, you probably started out with a very simple program where the computer would say hello, and maybe that took 3 or 4 lines of code. Well, if you had 3,000 or 4,000 lines of code, maybe you get something like a video game. So it just depends on what you're putting in there, but all programs are basically just a series of tasks. There are 2 types of programs in the world. The first is, and by far this is the biggest category, is called application software. So these are all the programs that help us to do stuff we normally do. So normally I communicate with people, so if I'm using email or a word processor to write a letter, that's application software. Normally at my job I fill out expense reports, so if I use a computer and Excel or another spreadsheet, that is application software. Even games, normally we entertain ourselves, so if I'm just surfing the web with a browser, or if I'm playing Minecraft or some other game, all application software. System software, on the other hand, controls the hardware. So without system software, the computer doesn't work. So like Finder, that's something you use to organize your files, right? If you didn't have a computer, you wouldn't need to do that. Operating systems are an example. They control all of the hardware. So system software, much smaller category, but it's important because that's what controls the hardware. An operating system is a group of programs that act as the connection between the user and the programs the user wants to utilize. So if you are playing Tetris, let's say, and you push P, maybe it pauses the game. But if you're in Google Docs and you push P, a P shows up on the screen. Well, you did the same thing, but different results. So the operating system needs to know what to do in those situations, right? We have a couple of different examples of operating systems. Windows is by far the most popular operating system out there. Linux is an open source one that a lot of people really like. And then Mac OS. And if you have guessed, Mac OS is the one that we use in this class. All right, we're going to skip that because you're not in class. All right, so the last thing you're going to do is a computer is like a person assignment. So you aren't going to work with a partner since you're at home, but what you are going to do is you are going to tell me what computer component is like the human component. So let's see. So I've listed input devices, main memory, CPU, binary code, operating system, secondary memory, and an output device. So you can use the brain twice, and it's, the brain is very special in all of the things it can do, but we want to sort of start thinking a little bit outside the box on some of these. And you can include something a person might carry, like a phone or a notebook. So let's do the input device together. So for a computer, an input device really gathers information. That's how we get information into a computer. So how does a person gather information? So maybe our ears hear, our eyes see things, our hands touch things. All of those are ways of gathering information. So if I put eyes, my reason, and the reason is the most important thing, because my eyes gather visual information. Now if I said eyes because I can blink a code to my friend, would that be an input device? Now I'm communicating out to someone else, so that would actually be an output device. So see why that reason's important? Eyes could work for either one. It all depends on why.